Hi there, good afternoon, everyone. I want to welcome everybody to today's webinar. So we've got a very interesting one today. Just a little bit about us before I get into our speaker and what we're going to be talking about today. 360 Energy designs and implements energy strategies for businesses in order to reduce an organization's carbon footprint and avoid unnecessary energy costs. This webinar is part of a series that we're doing in order to keep corporate leaders objectively informed of the many changes, including risks and opportunities that are occurring in the energy industry. Energy efficiency has played a role in business and policy options since the 1970s. Perspectives have changed over time, but the underlying principles remain the same. 5 industries are analyzed in this study, selected based on their production intensity, contribution to Canada's economy, GHG emissions, and trade exposure. Those industries are pulp and paper, primary iron and steel, aluminum production, chemical manufacturing, and unconventional oil production. Today's speaker, Alan Fogwell, he is the President and CEO of the Canadian Energy Research Institute, or CERI. He's going to be presenting the findings of the competitiveness impacts of energy and efficiency investments for those 5 industries. We're looking forward to seeing Alan's presentation today. Just a little bit of housekeeping before we get started. I just want to, for those people that have attended our webinars before, you know, I typically try to keep everybody muted just in order to kind of reduce any sound inputs that aren't necessary for the presentation. If you do have any questions, there is a little chat function or a question function. I would encourage you throughout the presentation to feel free to ask questions. Both Alan and I are going to be keeping an eye on the question box, so please feel free, ask questions throughout. And we will have a bit of time for some Q&A afterwards as well. But just wanted to make sure that everybody knows that little question function is there. Without any further ado, though, I'm going to hand things over to Alan to get started, and we will hand it over to him.
Well, thank you very much. It's a pleasure to be talking with people about one of our studies. This study was really developed based on uncertainty associated with what energy efficiency measures would be cost effective, and putting it into the context of the overall business environment of various companies. Now, this is based on a typical or normal operating condition, and we are far from that at this point. So this presentation does not take into account any issues or concerns related to the economy associated with the COVID-19 virus. So that's just a big caveat up front. At this point, a lot of companies are very concerned about maintaining their financial health, and maybe it's not the time right now for them to be considering discretionary spending in the short term. But needless to say, at some point, we will be returning to some form of new normal. And at that point, company decision makers will need to carry on managing their business, and energy efficiency is one of the options they should be considering. Let me just, okay, so a little bit about our organization. We're celebrating our 45th year. Our organization focuses on the economic and some of the environmental impacts of various energy issues in the country. We look at supply and demand. We look at oil, gas, and electricity. And in a lot of cases, these systems, these energy systems, overlap. So that's one area where we're able to actually look at the interlinkages between oil, gas, and electricity systems on supply and demand, and trying to give people a more comprehensive view of what could happen. One of the things that we pride ourselves on is that we are neutral. So we're not suggesting one approach or another. We are just trying to provide information to decision makers in business and in government and other stakeholders so they can make more informed decisions on various aspects of energy investments and energy policy. Our organization is a not-for-profit and a charitable organization, so we rely exclusively on donations to keep us going, and we've been doing that for, as I mentioned, 45 years. You can see from this slide that we have a number of organizations that have helped continue CERI's good work, including the governments of Alberta and Canada, also Saskatchewan and British Columbia, Canadian Association of Petroleum Producers, and a number of other organizations, including some associations and foundations. And what we try to do is to provide value to those organizations by doing this work and making it freely available to anyone, as well as any customized briefings that people want to have a look at in terms of nuances associated with some of our work. Our work is quite data intensive and there's a lot of information in them. And sometimes decision makers need a little bit of assistance in parsing out some of the key findings. And hopefully this presentation will give you some of that. So I'm going to start with a bit of an introduction in terms of energy efficiency, giving you a little bit of a understanding of how we went about our approach, and also the results and some conclusions at the end. So you can see here that Canada's industrial sector is a very significant consumer of energy. In most cases, it is predominantly natural gas and electricity, although there are some other elements of their energy use, including oil, and in the case of the pulp and paper sector, pulping liquor. Now, one of the things to keep in mind is that the Canadian industrial sector has been becoming more efficient over time. And the real question around that is whether that efficiency is a natural consequence of improved technologies as they improve their processes, or it's a concerted effort to minimize their energy use. In some cases, it's the former. In some cases, it's the latter. This is just an indication of where we focused our efforts, looking at the manufacturing mining sector. You can see that construction and forestry really don't have a significant energy use in terms of the overall economy. So we've really focused on manufacturing. And just to provide a little bit of a nuance, when we look at the unconventional oil production, it's really much more of a manufacturing process than you would find in more conventional oil production. And really what that means is you put in a lot of upfront capital, and you can maintain your production for long periods of time. And that's much different than more conventional oil production. And at the bottom there, you can see the different shares of industrial energy used by fuel type. Natural gas and electricity are predominant. You can see that natural gas has significantly increased over time. Oil is still there, but it's mostly natural gas and electricity. The 5 sectors, as was mentioned, that we're looking at really were determined based on their energy intensity and their trade exposure. One of the things that we wanted to sort of focus on in this case was the competitiveness of these companies. So companies are going to be looking at investments of whatever type, including energy efficiency, in terms of how it improves their competitiveness. And sometimes the energy use is not necessarily a competitiveness challenge or issue for these companies. And as a result, they're not as interested in improving their energy efficiency if they can put their money into other things that would improve their competitiveness more. This slide just gives you a picture of our analytical process, and what we're really determining at the end is the cost of conserved energy. That's the CCE. And what we've done here is we've divorced the discussion from individual provinces and individual locations where the energy costs will vary, and given people a checklist, if you will, a sliding scale of least cost to more cost in terms of energy efficiency activities that could be cost effective. That cost effectiveness line, of course, is going to change by province, by location, and actually by industry and by customer. And that means that the set of technologies that would be cost effective for an individual industrial activity will vary from one province to another. When we first look at the pulp and paper sector, you can see that we've looked at various elements of the pulp and paper sector, and there are two main processes: the chemical pulping and mechanical pulping processes, as well as newsprint and paper. And you can see from this slide that it reflects the change in people's use of paper products and moving more towards the digital realm. And that also has affected their GDP contribution and their overall emissions. And you can see that they've all trended downward in terms of GHG emissions over time, which is a positive for Canada. It has maintained, they've maintained their ability to produce and be competitive in other jurisdictions, because of course the pulp and paper sector is very much an exporting industry. Here's a little bit more looking at the energy intensity changes and the GHG intensity changes, and you can see that in terms of GHG intensity, it's coming down. Now, one of the things to keep in mind about this is that pulping liquors are assumed to be zero GHG emitting fuels. So if a company is moving away from natural gas, for example, and towards pulping liquors, then their greenhouse gas intensity will drop, but not necessarily their energy intensity. One of the things we wanted to show was what was technically possible, and you can see from this slide that we're identifying the lowest energy intensity observed plants in Canada, which is a little less than or about 27 gigajoules per metric ton of product. And the sector has come close to that overall number, but has increased since then. And a lot of that has to do with the fact that the energy intensity of the pulp processes is higher than the paper processes, and so that really represents a shift in what is the predominant product being produced in the country. Now, when we looked at this, we were not assuming that any new technologies were coming on board. We were just looking at what's technically and commercially available at this time. And we looked at both thermal energy efficiency options and electricity energy efficiency options because there are a number of those in each of the sectors. Here's what we produced as the benchmark or the cost curve, and this is the cost of conserved energy. And you can see here, there's two lines. There's a red line or a pink line and a blue line, and those represent different carbon pricing regimes. And we wanted to test to see if the carbon tax at $30 a ton would make a difference in terms of how many of these technologies were actually cost effective. Now, when we say cost effective, we're not suggesting any one party is going to be investing in this, i.e. it's the company versus government programs. What we wanted to show if the company went ahead with any of these activities, that it is, in some cases, it is cost effective, in other cases it is not. If that price of natural gas or the price of electricity is different in different jurisdictions, of course that will mean some of these technologies will become cost effective or maybe not. And the other point here is there's not much of an impact. There's some, but not much of an impact if a carbon price was imposed. Now, as I said, there's a number of technologies on this list, and here are the technologies that are itemized in the report. And you can see there that we're talking about things like continuous digester modifications, sludge recovery utilization, lime kiln modifications, and the numbers 11 and 12 are ones that would be cost effective in a CO2 tax regime of $30 a ton, and not if the tax wasn't included. And that will change, of course, as the carbon tax shifts upward, according to the federal government plan, which is to get to $50 a ton in the next few years. So when you're looking at some of these, the ranking may not change, but their cost effectiveness cutoff may. So just in summary, in terms of the pulp and paper sector, you can see that we can get about a 10.6 gigajoule per metric ton improvement in chemical pulping. That the economic viability depends on the fuel mix, because electricity is a higher cost, and it depends on how much of pulping liquor is used in some of these processes. The main caveat here that I'm going to come back to again and again is the cost of this conserved energy is a reasonable number, but if you were to employ or implement these programs and having to shut down your production as a result just for these programs, then you'll have to associate the lost revenues with the overall project costs and benefits. And if that were the case, there are most indications are that many of these energy efficiency activities, their cost effectiveness would be wiped out because of the lost revenues. So that would mean that you're looking at trying to properly plan for this when there's a regular shutdown of the plant. Now, when we look at chemical manufacturing, there are numerous products. So we actually looked at some of the subsectors in the chemical manufacturing sector, and we focused on chemical fertilizer and petrochemicals, which is plastics. And you can see here that GHG emissions have been reasonably constant over time. There hasn't been a significant change, but it is on an upward track for chemical fertilizer. On the other hand, petroleum manufacturing has seen some benefits over time, but really not too much. Again, the energy intensity has been up and down based on new plants coming online. And changes to the product mix. And overall, you see that the energy intensity for petroleum manufacturing has come down a little bit, but not a lot, whereas for chemical fertilizer manufacturing, it's come down a lot more. So when you look at chemical fertilizer, you're really looking at the ammonia as the feedstock. And in this case, when we compare Canadian plants to other plants, we are in a reasonable range. If you look at the bottom graph here, you can see that the energy intensity of the 10 best in class ammonia plants are in the 30 gigajoules per metric ton range, and Canada average is about 36 or 37. So Canadian plants are very, very good. We wanted to put in the thermodynamic limit of ammonia production, but that's not necessarily a realistic number, given that these plants also have to be competitive and putting in the most efficient technologies, on for the overall process. Now, I notice there's a question here, and I'll take this question as we go, so we have a much more give and take sort of discussion. Did we do a sensitivity on a carbon pricing change? How would this impact the drive to efficiency? Well, we've identified the difference between a zero tax and a $30 tax. So, and you can see from the pulp and paper analysis that it didn't make much of a difference. So it really depends on what is the level of the tax. If we did a $50 tax number, there may be a couple of other options that would be cost effective. But again, you have to look at not only the changes in carbon pricing, you also have to look at the individual plants, because these results will vary by individual plant. So coming back to the ammonia production, you can see in terms of this next slide that there's really not much of a difference of carbon pricing versus no carbon pricing. And if I'll go to the next slide and come back to this one, you can see that we've got 7 technologies that meet this cost effectiveness criteria, meaning they're lower than the cost of energy, or in this case, the weighted cost of energy, but it doesn't change if you apply carbon tax. So it depends on the energy efficiency option available and the sector you're dealing with. So coming back to the other slide, you can see that all the technologies we've identified, only 7 are cost effective. This weighted average cost of capital, cost of energy, is the blended cost of natural gas and electricity. And if you were looking at one versus the other, you'd have to separate those out. The other challenge that comes to mind when we look at energy efficiency options and the benchmark in terms of the bill savings for end use customers is that the natural gas price has come down over time and is very cheap relative to a lot of other options, and it's not expected to increase much in the foreseeable future. We didn't spend a lot of time looking at putting in a weighted average cost benchmark in terms of oil prices, but you can tell based on current markets that it would mean that almost any oil-based energy efficiency option would not be cost effective given the current prices. Now, the assumption, of course, is that the prices will go up, but that may take some time. So when we talk about ammonia production, we're talking about mostly natural gas impacts, and with the natural gas price being very low and quite available in North America, it's going to make some of these energy efficiency options less attractive. When we talk about primary metals, we're talking about iron and steel, and we're talking about aluminum in this case as well. And you can see that the energy intensity of these activities varies significantly. In terms of primary aluminum and alumina, it's much more energy intensive. than iron and steel. But the iron and steel sector in Canada has a much larger level of production than does aluminum. On the other hand, the value of aluminum has just been going up and up and up. And so we've got a situation here where aluminum is a much more valuable sector than iron and steel, even though iron and steel does maintain a significant contribution to the Canadian economy. GHG emissions have been coming down more significantly in aluminum, and that's primarily, as I noted earlier, that the energy use in the aluminum industry is much higher, and therefore they've had a concerted motivation to reduce their emissions as much as possible because they want to reduce their energy use as much as possible. Does the weighted average cost of energy include the global adjustment? Yes, it does. So this would be for Ontario, for example, with the global adjustment, sorry, it doesn't. It doesn't, because we were looking at it across the country. So we would be looking at the end use electricity price on average without the global adjustment. In terms of the supply or energy efficiency supply curve for aluminum production, you can see that the carbon pricing has no impact, again, in terms of the overall cost of or the overall benchmark for the energy efficiency options. You can see both the cost options for the no carbon pricing and the carbon pricing doesn't make a difference relative to the weighted average cost of energy. So there are some industries where the carbon pricing will have no impact in terms of the energy efficiency option selection choices, and some where they do. In the case of aluminum, there is really no impact. Again, you can see here we've got we've ranked all the energy efficiency improvement options, and the first 7 are, of course, cost effective from the point of view of the customer. And again, we're coming back to the end use customer. And most of them relate to fuel use, but one relates to electricity. And that's optimizing the motors in the facility. I'm not going through all the results, but I will show you the comprehensive results for at the end point, which will provide a key observation that I think needs to come from this. But the other point we wanted to identify was energy management systems can be cost effective and can create the about a 10% efficiency improvement in most plants. And these energy management systems are usually very cost effective. So we didn't actually go through a process to put the cost of conserved energy, because it would be relatively low and almost a flat line. So what we really wanted to do was just to emphasize the fact that energy management is something that organizations should be considering. Again, it comes down to whether or not you can put in these systems or these options without affecting the operational activities in the plant. Otherwise, you will have to take into account the costs associated with lost revenues. So of the 3 sectors that we've talked, or sorry, of the sectors that we've talked about in our study, we're looking at various levels of efficiency gains. Now, what it's really important to understand is really the next slide, and this is the critical point that we want to emphasize in the study, and that is you have to look at the cost of energy efficiency improvements relative to the cost of the competitiveness of the industries. And I'll give you an example. There's primary iron and steel there, and we've identified that there are cost-effective energy efficiency improvements up to 36%. So they could save 36% of their energy, and people will say, well, why don't they just go ahead and do that? And the reason why is you go to look over at the other line, and what does it mean in terms of the overall competitiveness of the industry? And it means relatively nothing. It would create about a 1% improvement in the production cost, and therefore it doesn't really affect their competitiveness. Is 1% good enough? Who knows? It's really up to the plant. I mean, there's going to be, of course, some uncertainty and some risk putting in any new technologies, making sure it fits with the rest of the system. So is a 1% improvement in their production cost sufficient to try and reduce their energy use by 36%? On the other hand, if you look at ammonia production, where we can talk about a 25% improvement, that would get you a 9% improvement in your production costs. That is significant. So when you're looking at not just these sectors, but any sector overall, you have to look at not just the isolated element of the energy efficiency improvement, but what it means in terms of the end production cost benefits. You can see that it is significant in pulp and paper, it's significant in ammonia, and it's significant in bitumen extraction. There's been a lot of work being done in the oil sands to improve technologies, and in fact, we have a report that will be coming out in October that will itemize a number of these technologies. So, in terms of the bitumen extraction, there is a relative production cost improvement of about 12%, with a significant reduction in energy use. But then coming back to aluminum and primary iron and steel, does it really make much of a difference if those types of companies and those production processes actually invest in energy efficiency? That's the question. And that's the one that energy practitioners have to answer for those plants, for those industrial activities. You have to relate it to how much things cost overall, and what is the marketplace that the company is working in, and what are their competitiveness challenges. So generally speaking, we've seen that there are, of course, a number of technologies that are cost effective without carbon pricing. Carbon pricing has very minimal impacts associated with the investment decision. That would change, of course, if you increase the carbon price, and it will be increasing over time. Now, in our analysis, we looked at averages for plants, and so if you are taking these cost of conserved energy curves, you're going to need to address that to the specific activities in the plant, as well as you're going to have to look at the specific costs of electricity and natural gas that the plants face. And that means looking at the rate structures as well, because if those rate structures are a significant portion of those costs are fixed, then you can't include any savings benefits associated with the energy efficiency. You can only look at the commodity. So the cost effectiveness is really influenced by the retail price of energy, and whatever that retail price is going to be dependent on what the rate structure is that's provided to the utilities. And finally, I really just can't stress enough that if installation affects plant operations, and if you're already in a situation where the plant is only going to get a small amount of improvement in their competitiveness compared to the international market, affecting plant operations could eliminate or drastically reduce the cost effectiveness for the company. When we looked at this, we of course did not include any investment incentives on the part of any government or any utility. Of course, that would change the cost effectiveness of these different options, because it would reduce the individual plant's activities, individual plant's costs. There's a lot more information on the sectors that I've talked about, as well as the ones that I haven't talked about. And the study is available on our website, and you can download it for free. It's at www.ceri.ca under research. There is a lot more information than I've provided today on this topic. So at this point, I'm available to answer questions, and I'd be happy to try and respond to whatever comments that you provide.
All right, thanks, Alan. So I will encourage, just as Alan did, if you do have any questions, please do feel free to type those into the questions window. Thanks, Alan, for being able to answer those questions kind of as we've gone through the presentation today.
Sure.
Just while we're waiting for some more questions to come in, just wanted to mention to everybody that Alan's actually going to be doing another webinar for us on May 14th on distributed generation. We've also got actually a pretty good bank of webinars that we've accumulated on our website over the past several months that we've been running these series of webinars. So I would encourage people to check out 360energy.net to see recordings. There's going to be a recording of this webinar put on the site as well in the next few days. So we'll make sure that you get copies of that as well. But we do encourage everybody to kind of check that out. So we've just got another question that's come in. Alan, can you discuss any future studies that CERI is going to be working on?
Sure. I can talk about a few that we've got coming up in the next couple of months, and then a few coming up over the next year. So in the next couple of months, you'll see a few studies. One will be looking at the impact of the rail network on commodity logistics. And the reason why we've looked at that, and it was interesting that we saw this civil protests of the rail network that caused a lot of consternation across the country because of the dependence that we as Canadians have on a rail system for our industrial sector. We were looking at it from the point of view of energy commodities. So the idea about more oil going on our rail network and how that would be impacted by everything else that's on the rail network, including manufactured goods and agricultural products and the like. So that's coming out in next week. We're working on the distributed generation study, and we are looking at the distributed generation business case from two different perspectives. One is, of course, the financial perspective of the companies that are working or investing in distributed generation, and also in terms of what it means for public benefits. So the public benefits in this case would relate to not having to invest in additional transmission or distribution. And so that's coming out in about a month, and I'll be speaking about that in the May webinar. A value-added project looking at how oil and gas in Canada can be increase its economic value, and instead of just shipping out the raw product, doing more, and that would be looking mostly at Alberta and Ontario in terms of those aspects. Later on, we're going to be doing a project looking at the resiliency of the electricity infrastructure system as we see more storms and more severe storms associated with climate change. and what is the investment requirements for that. We're going to be quantifying the economic benefits associated with electricity trade, and that's all interprovincial as well as international trade. And another project looking at our where the natural gas industry might be going in the future. As I mentioned, natural gas is reasonably cheap these days, and it's expected to be there because we see a lot of additional production in the United States, and that is supplanting Canadian production. So what does it mean? I'm going to go back to some of these questions. The full list of projects that we're working on right now and working on in the future are on our website as well. How do they determine what studies to do at CERI? We work with our donors in a lot of cases, but we work with the various industrial associations and with governments and find out what is the most prominent concerns that they've got, and we reflect that in the projects that we move forward with. We also have a list on our website of potential projects that we could do if we had additional funding. So it's not like we are at a loss for ideas. We're more in the situation where we'd like to do more, but we are just limited in terms of our funding. I think it was on slide 20. This is another question. I think it was on slide 24 where efficiency in the steel industry was discussed. Does the data on this slide reflect the change in percentage that has happened over the years as far as how much steel is made in integrated steel mills versus electric arc furnaces? Yes. What we've done here is we've taken the blended numbers of everything that's happened in the sector at a very high level. So that's what we've shown. So it includes any change in production within the sector itself. So it's the overall numbers for the sector, not specific areas related to integrated steel plants versus electric arc furnaces. Can Alan also discuss the resources or expertise CERI has? Absolutely. We have 12 researchers, and they have a blend of experience in terms of oil and gas and electricity. A number of PhD folks are much smarter than me, and the experience sort of falls into two categories. One is economic and the other is engineering. And the reason why we've got that in place is because to really understand the economics of decisions, we need to understand the underlying principles related to it. So if you don't have a good understanding of the engineering aspects associated with various activities, then your economic analysis is really going to be fraught with mistakes. And I think we are actually unique in the country where we do that blend in order to ensure that the information we provide is as good as possible. Is there any technology platform you recommend to real-time monitor and manage energy usage at the companies? No. We haven't really looked at any individual technology brand. We tend to stay away from that. We're looking at technology types. So any one individual brand will really be up to the plant and their service provider. In Ontario, industrial energy efficiency can be enhanced with battery energy storage systems that greatly reduce GA input costs. How did you account for that in the study on industrial competitiveness re Ontario? Well, we didn't. We have done work looking at energy storage, and for the most part across the country, energy storage is not cost effective right now. It's just very expensive. However, That doesn't mean that in some cases, in some industrial plants where you are looking at a very unique element in Ontario in terms of the global adjustment, that they could be cost effective. But generally, there's a challenge in terms of battery energy storage systems across the country being cost effective. Again, you'll have to look at individual plants, but that's what we found. However, what that also means, what we've also shown in that study, which is on our website as well, is that the technology evolution of battery energy storage systems continue to move apace. And we see that with improvements in those technologies, their cost effectiveness is actually going to improve over time. At this point, our best guess is that that transition from not being cost effective to being cost effective is going to be another 5 years. But also depends on the maturity versus cost curves that we've seen and we've used in our analysis, and those might be accelerated, which means that the energy storage systems could be more cost effective sooner. What I would say is you really do need to be careful about making blanket statements about battery energy storage systems right now, because it's very site specific. Do they provide any, the next question is, do they provide any training to the marketplace? Well, we did in the past, and it's always an option for us in the future. If people are interested in training, that's something we can develop. We've been in discussions with some international organizations about doing training and capacity building in other jurisdictions, and it would be no different than doing something like that in Canada and Ontario and in Quebec and other places. But at this point, we don't have any formal training programs in place, but it's always something for us to consider.
All right. So I think that I believe that's all the questions that we've had today so far. So we're going to just kind of end things up a little early, but wanted to thank you very much, Alan, for a great presentation today. I think everybody got a lot of good information on that. So very much appreciate you talking here today.
Oh, you're most welcome. And if you need any more information from us, you can reach us at info@ceri.ca, or you can actually just send me an email at afogwill@ceri.ca.
Yep, and feel free to, you know, if you didn't get that info, you can definitely reach out to us here at 360 Energy, and we can definitely put you in touch as well to help out. So I wanted to thank everybody again for attending the webinar today. I appreciate your time. As I mentioned, we will have a recording of this webinar up in the next few days. If any other questions do come up, feel free to reach out to us here at 360 or directly to Alan as you see fit. But once again, thanks again, Alan, and thanks again to everybody for attending today. And hope you all have a great day and stay safe.
Thank you.
Thanks, everyone.